Hello everyone, this is Team Icarus and we have built thermal for Google Solutions Challenge 2026. And our problem statement was smart resource allocation and we have gone with open innovation approach. So let's see what thermal basically does. So thermal is basically a data center visualization tool that we can use to manage and control the workload that is being put on each data rack. We do this by looking at the thermal heat signature and seeing which one has the highest amount of load and redistribute it accordingly. What it does is it lowers the use of passive cooling systems so that the entire system is more efficient and it's going to be working flawlessly with that. We are going to be reducing the water consumption for liquid cooling and as well as the power consumption for HVAC systems as well. It uses AI and the preset algorithms to control the workload between each data rack, and we're going to see how it works. First things first, we are going to open the monitor. Monitor is the dashboard where you can see each rack individually and how it does. On the right side, we have this override section where you can manually override the entire system by using your own calculations and controlling each rack individually by yourself if you don't want to rely on AI or any kind of algorithms that we have. The next thing that we're going to look at is the sidebar. So sidebar is going to contain widgets. As you can see, first one is for water and power consumption. We also have the current and the target power usage that we have over here. We have the each individual rack temperatures and all kinds of graphs and visual aids for understanding the data much more better. On top also we have kind of small widget section where we can look at the small nuances of each thing. We have water which is being used uptime of the server racks. We could also keep going and we can see the AI strategist and when the next policy is being dropped by the AI. And we can also see the average heat, the peak heat that can be achieved, the hot tracks and all those kinds of data telemetry. And we can also see the status of AI right here. So we are using Gemini, so it's going to say if Gemini is online or offline. If it's offline, then it's going to use the pre-existing algorithms, and that's basically a fallback system that we have. So let's show you the simulation as well. So this is a simulator. And in simulation, this is where you're going to be controlling the entire data rack over here. You can add or remove the data racks individually, or you can basically customize the workload as well. So right here, we can add jobs for each rack. We could say machine learning algorithm, or we could just say video transcoder, database replica, or any kind of things. If you don't want to select it manually over here, you could actually add 3 random ones just to test how the things work. You could also add the heat temperatures here. You could control for each rack and you could go from preset scenarios as well. You could do cold start for cooling down everything individually. You could do hotspot where one thing is going to be having a really hot temperature. You could do gradual ramp where everything ramps up gradually. And all these scenarios can be tested over here from the dashboard right here. So we can also see the visual logs here. It tells what is being done decision wise and algorithm wise. And this is going to be useful for understanding and determining what is being basically done. So this was a project trying to reduce the use of passive cooling system and being efficient with data centers as it's a future and we need to be efficient with what we do. And this was a project for smart resource allocation using Gemini, which was actually quite easy. And this is what we have come up with. Hope you like the project. If you do like it, we also have a GitHub repository where you can contribute or start the entire project so you can see the upcoming updates that we do on this. Again, thank you for your time.